So we have a Cupaniopsis here, Takaroo. I'm assuming it's Anacardioides, Peter.
Yeah, I think it is, yeah.
Those of you who don't know it, there's one called parvifolia, and it's probably a nicer species in some ways.
It is a very nice little tree.
And we've got a whole pile of material being pushed out here, a whole pile of exudates from a codominant stem. Oh, you can't tell it because I haven't shared you my screen. And Peter, I know we can do that without, yep, I've got it.
Should be able to share.
Yeah, I should be able to share. And I should be able to just share you my screen and say share. And now you should be able to see that.
Yeah.
And let me just see if I can make it pop out and whether that'll allow us to get any larger, because it's not as large as I'd like it to be. So a tree that's stressed, it looks like it's in a park reserve, Peter. Does that sound?
It's in a resort thingy. It's been built probably 3 to 5 years ago, and there's been some disturbance under the canopy on this side.
Okay. So that might account for some of our problems. Here we've got an exudate. The colours of it, the red and the dark sort of burgundy colours suggest that's a phenol. It's probably got some tannins in it. And that's from both sides by the looks of it. So it suggests, Peter, that there's probably some form of internal injury between the two stems. Interesting that it's still producing that sort of protective zone given the canopy density. The canopy density is not particularly good. And it looks like we've got a whole pile of things happening to it. I don't know whether I can make that any larger at all. I don't think I can do that with any ease. Let me just see if I can remove a few things, whether that will allow me to get the access to the bottom end of my screen. Need that open because that's where we are. Don't need that one open. Save. Don't need that open. Don't need that open. Oh, yes, I do. Crap. Don't need that open. Don't need that open. Don't need that open. Okay. No, it's not going to let me get down the bottom of the page. So why not? Whoops. How about if I just shorten it a bit? Okay, that's going to do the job. Okay. Now, hopefully that'll allow us to see that as a little bit bigger image. No, it still limits the image to the same size. So, yeah, here as I'm looking at it, there's some foliage issues. And Peter, you can describe better, but is there a fungal deposition or is it look more like a calcium deposition?
No, I think it's more like a calcium deposition. It's not, I don't know that it's fungal.
Okay, and we've got a leaf that's chlorotic. And those of you who haven't seen it, there's a wonderful book by Nick Malnichek on soils where there's a one-page summary that shows the various things in eucalypts as to how these things happen. But this is unusual seeing chlorosis in the midrib. And whilst it's good to do as a start, trying to treat soil problems from visuals alone has some drawbacks. It has some risk associated with it. I won't say never do it, but I'd say do it with caution. The ideal solution here would be to do a soil test and a foliage test, look at the nutrients, but more importantly, we've got a declining system. And so the question is why? And Peter said, well, there's been some soil buildup. I suspect, Peter, that soil buildup probably wasn't done in the most sympathetic manner. And so now we've got some flow-on problems. With that?
Yeah, I agree. It doesn't look like they've had any input from an arborist in this project to me.
Yeah, that's not uncommon. And even when the input's been given, I think it's got to be fair again to say that it's not uncommon for that input to be ignored.
Mm.
So we don't
I'm
know.
not sure if this adds anything, but what I did notice that seemed to be a little bit unusual was that the only live leaves were on the outside of the canopy. All the stuff in the middle, in the centre, was all dead.
Yeah, look, trees normally do that during times of stress. There's a good reason for it, and that is photosynthetically, the external leaves are more efficient. And so you'll notice, for example, and we get it a lot, and hi Melanie, you'll see it down in Tasmania, is when you get drought stress on or water stress on a capressus, the internal foliage will all of a sudden start to turn brown and drop rapidly. And that's because the photosynthetic material, the leaves, have to support themselves, the branchlets, and contribute back to the system. If they can't support themselves, there's no free handouts. And so it's easier for a tree to shed, deal with the stress, and then grow new leaves when the time comes. And that is a very quick process depending on the species of tree. So here, Peter, the desire would be to try and deal with the problem, and I suspect the problem is an interface problem. And I don't know whether we've ever looked at soil interfaces, have we?
I think we have talked about it at times. That's
okay. Michele, do you know what I'm talking about when I say a soil interface problem?
Is it when you bring in new soil?
It's created when you bring in a soil with a different texture and bulk density.
Oh, yeah.
So if you put, and the worst ones are things like putting clay over sand, you would think that water would flow through the clay into the sand because the sand's really quick draining, but water is a polar chemical. So it's got this great polarity and the ability to take another chemical and pull it apart. And that makes it a good solvent. That's, water is one of our best solvents. And when it does that, it clings. It holds on to chemically, holds on to adjacent things. So, for example, you've seen in a glass, the water has a slight little meniscus that is concave and it starts to crawl up the edges of the glass. Who's noticed that? Anyone?
Yep.
Yep. Okay. That's its clingy nature. And so when it comes to clay, clay's got a huge surface area, lots of particles in it. And so water would far rather hold onto that clay than go into the sand below. Now, that's really good. You can start playing these sort of things. For example, if you want to create a perched water table for a bowling, sorry, not bowling green, or bowling green would work as well, but for a green on a golf course. So greenkeepers understand this really well, but arborists and landscapers really aren't good at this stuff because we've never seen it. We don't go out and watch it. So the dilemma becomes you get incredible drought stress if you put a fine material over a coarse material. The water doesn't flow through. Okay, it becomes essentially a waterproof layer. It also means that if you've got clay soils and you go dig a trench and you put in some gravel and then ag line in a geotextile fabric, those tubes, and you cover it with more gravel and you put clay on top, it won't work. The water does not leave the clay and go into the pipe until it's absolutely at field capacity, and then there's still a reluctance. So those sort of drains don't work. And in spite of that, they're still commonly recommended and used in landscaping, in landscape specifications. So they're just completely non-functional. So my guess, Peter, is that's the problem here. You've got an interface issue of some description. And the first thing I'd want to do is a process that's really old-fashioned called core
dig
venting.
a hole.
Yeah, dig holes, lots of holes. Well, ideally dig a hole to diagnose whether that's the case, but also to puncture through the layers. So if you've got here, say it looks like you could have a metre or more of fill, would be to put some great big tubes down and fill them with gravel.
Mm.
And those tubes, I'm not talking about physically tubes of plastic. I'm talking about drill a deep hole, fill it up. It was the old, what we used to call drill, pill and fill, except there's no pill necessary. You don't need to put fertilizer or anything in those environments. So, you know, without doing more work, we do know some things we can say for certain. The tree's stressed. It's got some chlorotic leaves. It's lost all of its internal foliage. It's lost some external foliage and dead tips, and that's a sign of extreme stress. That's one of our real positive signs of a tree not doing well, is those dead tips. And, you know, bar doing further diagnostic testing, you know, there's not much that I'd even recommend as an interim solution on that. The other thing that they could have done, and it would never happen on a site in general, but if they've added soil over an organic layer, that becomes significantly worse. Organic material is never meant to be buried. And so if when they're filling, they fill over the original mulch and grass and everything that was there, you get this beautiful layer that starts to degrade anaerobically. You get a whole pile of oxidation reduction problems. You get methane and sulfur dioxide being produced. And all of these are phytotoxic gases. So not a desired approach at all. So yeah, that's how I would approach that. You know, I guess it's up to the client to decide whether they want to go further into it than that.
I think they would be prepared to take some action. It's a feature tree in this upmarket resort thingy, and they're horrified that it's turned its toes up.
Okay, in which case I'd start by at least drilling one hole, and you know, if you've got a you know, reasonable sized cordless drill and something like a 50 mil bit would be ideal, or an auger, you know, the sort of one-man augers that have got an independent motor and a swivel on them, where you can go sort of maybe 50 to 100 mil diameter hole, and try and find what the soil profile is like and whether there's an interface problem. If you get to an organic layer that has a whole pile of weird gases come out, and you'll smell it, it's unpleasant. It smells like a combination of spilt oil and rubbish tip. If you get that smell, then good luck. If all that you've got is a fine material over a coarse material, filling that tube up to the very top with coarse material will make a big difference.
Mm.
How long do you think, and I don't want to provide this, you know, to all parties, but how long do you think it would take for a tree that was drought stressed? Now, this is beyond drought stress, stress and strain. Remember the difference we defined? There's a difference between the two. Stress is reversible, strain is not reversible. It doesn't mean the tree can't rebuild, but this here, these leaves are lost, that's strain, okay? If it were at the stress stage, that is, if it was dealt with soon after the leaves started falling and started thinning out, how long do you think it would take to reverse that?
At least a year before you start seeing some differences, and 2 to 3 years to recover.
New absorbing roots and foliage, if it's a nodal tree, so it's going to develop a new root system. That's, you know, it's drought stress, got to produce new roots, or it's got to get rid of the problem.
If it's only stress, it only should be a growing season, a few months at the most. Sure.
Yeah, look, we just did a whole pile of trials on it, Peter. I had some fun over the Christmas break, and we did do trials, and we photographed it and recorded it. 6 weeks will get you there. Whole new canopy in 6 weeks, which is mind-bogglingly quick.
Are you saying that there would be new leaves within 6 weeks?
Yeah. Would you like to see some shots? Let me show you. I'm not going to go through the whole thing, but I'll show you a most recent and a not so recent. No, we need to go back earlier than that. So I went overseas, came back to an extended dry period and found my white sapote, which will hopefully crispen up soon. Might need to do it again, crispen up, come on. Yep, there it is. It's drought deciduous, that is, during dry periods, it'll just drop the bundle and go into a diapause and hope for the best. You can see there's not many leaves left on it. In response, we watered it. We simply put, you can see there's a hose there. That's the first day. I thought, oh, I'm going to give it a try. So I did this with a white sapote, a Maria, and a jacaranda. The jacarandas were the last to be started because we've got limited water. The white sapote was the first. And this is it, 6 weeks to the day afterwards.
Wow.
Mark, but if this species had dropped the leaves during a dry period, wouldn't that not really count for this experiment because that's how they adapt?
Yeah,
The other tree,
does.
doesn't really drop leaves.
Yeah.
Even when they drop leaves, it's because they're severely stressed. It's not like a deciduous.
Yeah, so dropping foliage from stress is different than dropping foliage because we've got a major disease, and trees do drop to stress. So that's what I'm giving us, is on the basis that we haven't got to strain. We've got a stress tree. How long will it take to reverse? And the answer is about 6 weeks for the absorbing root system to be stimulated. Interestingly, it was only about 2 weeks between the start of the stimulation and the first buds. So in January there, we're just starting to get some response. About 2 or 3 weeks later, they're just starting to get some swell. And then by the time we get to the end of December, so 3 weeks, and you can see the shoots starting to burst. So between 2 and 3 weeks was all that it took to develop a new absorbing root system. Essentially, that's there. Yes.
Sorry, I was half eating and only half listening when you were talking about that. Did you say it was just water that you added to it? You didn't mulch it?
Yeah, just water.
Just water, far out.
It's an amazing thing. Kim Coder in 2011 gave a talk at Parramatta that you can download on the ISA podcast. And it's a really good talk on soil science. And one of the things he says is that the chemical that is in greatest deficiency in the soil is water. And that would certainly be true for many Australian trees. And that's not that that's all bad. I came back, the eucalypts and the corymbias were perfectly fine. They had no troubles. They have a different system of dealing with it. One of the things they can do is they'll stop photosynthesizing towards the heat of the day. And then only if water's available will they start again in the afternoon. So they can come into a morning photosynthesize, lock up and stop. They're the good typical Spanish type of tree in the sense they have this siesta in the middle of the day, and then they decide, whether I'm going to go back to work or not. So, just the important thing is to realize how quickly the small absorbing roots can be stimulated.
So, Mark, do you think that 6 week interval can be extrapolated to all species or most species, or what?
Yeah, look, there's some good question. There are some variables. The first variable here that gives it a slightly better performance is this is summertime and we've got lots of warmth. And we know that soil temperature is a component. Typically, most temperate species like soils to get to about 16 degrees, which they do pretty well most of the year. About 2 or 3 months they might lose out. But most of the year the soil temperature is quite good for growth. Having said that, and I might have mentioned this before, I remember having this discussion with Al Shigo as to whether absorbing roots were functioning during winter because the tree's still running biological processes as slowly as it is. And Alex, in his good-witted nature, said, "We'll go dig some up." And so he sent me out into snow to start digging up root systems until we found some absorbing roots. The answer is yes, even in winter, you get some absorbing root development unless you're in permafrost. Okay, if your soil freezes, then I suggest that it probably isn't going to happen. Although having said that, at depth, it probably still does. I mean, I'm forever amazed at what trees do that we don't think they do. We've got a perception of trees that is anthropomorphized, that it's based on how we see the world, not the way that trees are. And that creates us issues all the time. And I've just been dealing with it with a government department today who are really upset that I haven't provided age class in a arboricultural impact assessment report. And I said, I don't see the relevance of it. Oh, yes, well, you know, you can't get as close to old trees. Well, we say that because when we get old, Rob, say yes on this, as we get old, it gets harder on your body and everything that happens to you takes a little longer to deal with. And trees aren't necessarily the same. What happens is the physiological system might get stressed, but the tree itself isn't suffering like we suffer. It doesn't have the same thing. So an old tree can be just as successfully played with as a young tree. The genetic material is not degrading like it is for you and I. We're not got joints that are degrading. The tree is simply a generating system, whereas we're a regenerating system that gets to our peak at the end of adolescence, you know, 18, 21, somewhere in that range, we're finished. Whereas a tree can be 180 or 1,080 and still be doing very well. And you see that beautifully done with things like the redwoods or some of our big ukes. I mean, those of you who ever saw old Blotchy down in wherever it was, you know, is it 400, 500, 600-year-old tree, still growing incredibly well. So we have a very different view. So yeah, I think a general extrapolation, if you said 6 to 12 weeks, that you could pretty well rebuild a root system, provided there were sufficient reserves and woody roots left, the answer is yes. And our woody root, when I define a woody root, I'm talking about a root that's probably about 1 millimeter or so in diameter. And that is by definition a woody root. It's got xylem. As soon as it's got xylem, xylem is wood. Okay. How long does it take to become a woody root? A few weeks. So the roots that we stimulated in the earlier stages of this tree will now be woody. Does that make sense?
Mm.
Yep.
And it's now produced new absorbing roots. And I think that in part accounts for that dieback that we're having in the Sydney region called cytoroxylin dieback. And some of you might have seen it where you've had these really big wet periods and trees are starting to stress now. And you're thinking, wow, that's odd. Is that the trees have almost become lazy by irrigating with rainwater. And then they've gone back into this harsh environment. And some of them haven't coped with that well. And that's all the more so when the soil saturation occurs and you get root systems that are being damaged from it. So hopefully that answers that question. Yeah, go on, do that. Next one. Don't know who submitted it. Tasman. No? Oh, no. This is Mark. Yep. Thanks, Mark. These little brown things here, I hope, can you guys see that okay?
Yeah.
Yep. They've got this wonderful name, technically called an exuvae. Simply means a casting of an organism, EXUVAE, I think it is. I think there's a diphthong at the end. And so this is just where a nymph has come out and it comes out and it opens up and sheds. I was, I'm going to say 56 or so before I ever got to see this in the real world for the first time myself. It's definitely worth doing. We're in a park when it happened, and a little black prince we saw near the ground, and there it was, just coming out and shedding. It was delightful to see. And this looks like cicada as well. Cicadas are a fascinating insect. They take a lot longer to mature, and part of that is their diet. It comes from the xylem, from tubes that are predominantly got water and solutes, and not a lot of dissolved sugars. So low levels of carb means it takes a long time to build to size. So many of them have long life cycles, some of them quite long. And then we have these plague generations that alternate. So yeah, great creatures. The nymphs do as much damage as the adults, but typically, because they're on the roots, you don't see them. And because you don't see them, you don't get to know what's causing the damage until you get, a period where they come out and all of a sudden you see thousands upon thousands of cicadas come out on a limited number of trees. And you think, wow, that's been happening under that tree for 6 or 7 years. It's been taking out water and more and more and more water. And once they come out as adults, and I know I definitely have talked about this, because they're feeding on the xylem, they've got to get rid of the excess waste, and the excess waste is water. And so you have this cicada rain that comes out of them. And in high numbers, that'll saturate the ground beneath the tree. And you think about it, that's a lot of water to be sucking out of a tree, It's in the hundreds of litres a day that the feeding cicadas can do. So can be fairly problematic. Michele, this is your one. Oh, no, yes, come on.
Yep.
This looks horrible. Is it a brachychiton?
Yeah, I think it's the populensis.
Yep, okay.
There's a couple of weeks really.
Yeah, let me just move that out of the way. So yes, it's suckering up for some reason, and we'll have a look at it. As you say, there's a couple more shots there that give us a little bit more information. That's looking awful as hell. This is in a verge somewhere.
Yes, that is in the median strip. That's to line.
Yeah,
and that's a close up of a branch.
And we're getting all this bud production. Does anyone want to guess where you'd start with that?
Herbicide.
Herbicide damage. Yeah, that would be my first one. And because it's in a median strip, my first guess would be something like metsulfurin or a triazine, probably a metsulfurin. And I'm guessing they put it on and they're getting the application rate not quite right. And they're not reading the instructions which say, don't use beneath trees. If you must use things like once a year weeder and path weeder and weed and feed, always applied once the soil has been moistened to near field capacity. The reason why is you reduce the concentration rate and therefore reduce the risk of getting a sublethal dose or lethal dose. But yeah, that's exactly what that looks like, is this shortened nodes and clustering of buds. And I know we looked at that last year, so spot on. That's where I'd start. If that wasn't the situation, if you spoke to the city and the city said, you've talked to Melanie and you said, have you guys been using any herbicides? No. My next one would be to look for mites. Clustering of the buds like that is not, can also be found from mite activity. If the tips were missing and the laminae were missing, then it could also be possums. But the fact that this is the middle of the median strip, I'm going to rule possums out as a probability. But they can.
But you could see the dead weeds underneath the trees.
Yeah. Someone's had this great idea. Let's go down and get a once a year weed product from Bunnings, and let's put it down in the median strip so we don't have to worry about controlling those weeds again for a whole year. And some will grow past this. It is sublethal, so they can respond and come back from the stage. And I think you've got a close one. Oh no, this is another one. Okay.
That is about probably 80 to 100 mil
100 mils long. Yep.
Like a good finger size.
They can walk a couple of kilometers an hour, and they do walk those sort of distances quite happily. This is a Lepidoptera, and the particular one is a white-stemmed gum moth. And as arborists that climb, this is a problem because all these trichomes here, these hairs, are put into their cocoon they spin, and that is put in there to protect them. That's a fairly juicy grub otherwise. I mean, if you could skin and fillet that, you could get a meal out of 10 or 15 of those. So this is a part of their protective system. They use it on their cocoon as well, and they're often well camouflaged, and arborists touch them and all those barbs end up in your hand. The traditional method of removing them was to take your pot of tree wound dressing and paint your hand and wait for it to dry and then peel them out. PVA glue works as well. They tell me that elastoplast does a reasonable job, but boy, they're horrible when you get them in your hands. So yes, and as I said, they're quite mobile as a caterpillar. I'm amazed at how quickly they can walk and how far they will walk. The moth itself, though, does very little damage to the caterpillar does very little damage to the tree. You might find a tree with 20 or 30 of them if it's a big tree, but they tend not to graze the tree to cause levels that are problematic. I've never seen it. I guess everything could potentially do it, but it's not something I've ever seen and not something that ever has been reported to me. So if I found that on a tree and it was a client with kids, I'd be saying, look, what a wonderful opportunity to see how nature works. Maybe grab an aquarium, throw a few in, give a few leaves, watch it pupate, watch the moth come out. There's nothing better than that. In terms of trying to eradicate them, I have never done so. And I can't see any point in trying. What would you do if you had to? Dicamba. If you had to, it's approved for Lepidoptera and it's a low toxicity option.
Mark, just back on some of those first photos, would a dicamba glyphosate mix do a similar thing to those trees? Like an off-label amount?
Yes, glyphosate can cause shortening of the nodes and lots of suckering and a sublethal. It tends to cause more tissue distortion than you're seeing here, though.
Mm-hmm.
And this looks like it's suckering out. You can see how they're now, it's sort of like it's broken the cycle. Having said that, the color of the leaf is still pale. It may well be that it's chlorotic. It could be that sublethal and triazine. Without testing, I'd be guessing symptomatically. But yes, the sublethal glyphosate could be more a problem. What was the other one you said?
Dicamba. So I worked for a council that used dicamba glyphosate mix around trees. And when I started, that was a problem with the tree. And now I've driven past and I can see they're all a bunch of aces. And now they're looking brilliant again. After
dicamba causes abscission. You get an ethylene response and you start to get leaves dropping off. So I would have thought that would have been a loss of canopy, but not as much of if I can get the right image, not as much of this clustering of little buds. So dicamba is great. Every November, I know it's going to happen. Somebody's going to call me, their tree's dying. I go out. You have a look and you think, wow, okay. And you say to them, in fact, I had one this week, jacaranda. And, do you use any herbicides on the lawn? No. I use once a weeder on the pathway. I said, yeah, okay. That would probably account for the erratic dieback on one side. It's just the tree's a little thinner than it should be on that side. And again, my advice is, even if you're going to be using it on the footpath, irrigate beforehand. It goes through footpaths. So water's in. So, and then things like metsulfurin, the label says don't use it all. And triazine, they say don't use it all. And I know I've mentioned it, but it's worth remembering again. Mandela yellows was a disease that was going to, microplasm-like organism that was going to wipe out eucalypts through Australia. Until they found there was a misapplication of a triazine herbicide by the Roads Authority, and they'll just simply over-applying it and misapplying it, and you're getting this sublethal effect that was causing problems with the trees. So, yeah, it's certainly, and I know it's decomposed granite, and I know that doesn't let a lot of water through, but it does let enough through that you end up with some herbicide damage below. So, had that not been there and had that just been good permeable soil, we may not have had trees at all. I've seen metsulfurin at 1.3 or 1.5 time application rate just wipe out every tree, just by applying it to the surface, not drenching it or anything. So, yep, okay. Peter sent these. These are from Andrew. I don't know whether Andrew's on the line.
Yes, I am, Mark.
Yeah, great. Thanks, Andrew. Okay, these were funny little balls on the ground, the spongy looking balls. Anyone want to guess?
Is it a fungi?
It is a fungi, yeah. This is one of the puffball group of fungi. I could take a guess at genus, not at species. Nowadays, it's all changing dramatically in terms of fungal identification, but that is one of the puffballs, yeah. And they're generally good guys. They're beneficial. They're mycorrhizal. So you've, Andrew, you've destroyed the spread of spore in that area. Don't be worried. They produce billions and trillions of spores and get spread around. Now, Andrew, this one, a little bit more confusing for me. And I'm going to just see if I can, no, won't let me copy it either. Hang on, I know how to do it. If I reply to it, should be able to reply. Now will it let me copy it? Yeah. Yeah, everything on this screen is not where you want it. Yep, I'll use the bottom of this document, that's fine.
Mark, just commenting on the puffballs, what I find incredible is the way they'll come up through asphalt.
Yes, they have a turgid pressure that's equivalent to any other plant. So whilst we've taken fungi out of the plant kingdom, put them in their own little kingdom, the cell's the same. The cell's the same for human beings. And I say this to people, yep, okay, I get the deal that you think that roots can lift heavy, huge things like a building. But roots are made up of cells, the same sort of cells that people are made up of. Now, I know that the man that lifted the heaviest weight, Paul Robertson, I think was about 2.38 tons he lifted or something like that in a back deadlift. You know, that's a fair bit of weight. What would happen if we'd put, say, 4 ton on him instead of 2.38?
It'll crush probably.
You crush him, you kill him. Yeah. It's exactly the same with roots. There's only so much they can lift. And the problem, the other side of that problem is roots can only lift so much, but the soil beneath them can only support so much. So the soil tends to give way, the roots sink down, and so it goes on. So this little thing here is on a eucalyptus, is it, Andrew?
Yeah, I believe so. Yeah.
Yeah. Well, what do you think it is, guys? Let me see if you guys have got any idea.
It is an insect, and that's a gall form for them laying eggs, probably.
Yeah, so it's a gall-formed insect, absolutely. And given by the shape of it, I would guess that these were probably male and probably apiomorpha, but it's not clear enough and it's not obvious enough. That would be the most probable based on shape and size.
They were quite hard to the touch as well.
Yeah, what it does is these insects manipulate the plant tissue and make it do some pretty amazing things. So they can create some absolutely delightful structures. Let me show you one or two. I'm going to go out of that side now, back across that side. Well, I may have one come up fairly quickly. Yeah, so these are all galls of various sorts. And you can see, you know, that's a pretty ornate gall. That's actually on Casuarina, and that's what would have been, we would have called the Felicity, or the little scale and stem. And all it's done is it's shortened the length of the node and made every other part grow bigger. And then the female's inside there. The male does a similar thing, but not as pretty. So it's pretty neat. Sometimes this is erroneously contributed to mimicry. It's not. If you want to identify the alocasuarinas that these grow on, you can count these little scales, and that's the exact number of scales. It's simply the stem itself. It's just been highly modified. And Apimorpha, I'm just trying to think. Oh, here it is. Look at that, just brilliant. Two sides to it, massive big thing. Looks like a leaf. So yeah, pretty neat processes. This one's a little unusual. This is an insect with essentially 4 legs, although it's actually got 6. One's so suppressed. That's some photographs of it from identification. And some of these can be quite small. So here's a gall that's on a eucalypt, and you can see they don't look particularly big. This giveaway here are these rounded openings. The edges are round, they're not been chewed. Anytime you have an opening in a gall that is not chewed, you know you've got a hemiptera gall, sap-sucking insect gall. The reason why is they have to have an opening to allow the young to get out and the male to get in, or they sit on the outside and do what the male's got to do. So whereas wasp galls, they'll chew a hole. What else forms? Some Diptera, a few other organisms. But wasps, they're our main alternative to hemiptera. So that again allows you just to break it down, and you know now I've got some form of hemiptera gall on the tree. And I've seen this get to huge levels on trees. In fact, this specimen was from a tree that was been heavily grazed. And when you cut them open, of course, you can see the chamber and all the usual things associated with them. Here's one that wasn't so obvious, but again, you can see this rounded opening. This is tiny in size. This is probably 0.5 mil to 1 mil in diameter. And again, not particularly obvious. Whereas here, I've got no pre-existing opening. And so my first guess here would be start at wasps. Now, it may not be, but that would be, if you looked at those two as your indicators, that'd probably cover 90% of the galls of concern. Some fungal galls, and fungal galls don't have this beautiful regularity to them. Okay, they're very erratic. And why? This is driven by a relatively sophisticated organism rather than a simple organism like fungus. So hopefully that's helpful on that. Okay, back to the images that we're looking at. So hopefully that answers that for you, Andrew.
Thanks, mate.
No worries. Now, I'm going to do the same with this because it's just too small. Copy. I'll copy them both. Let me do both. I'll do one on top. Copy. Across to the Word file. Next page. Next time, guys, I'll do this in advance. I apologize for that. Okay. Pretty obvious as to what it is. Anyone?
Wasp?
Sorry, what was that, Michele?
Is it?
It's a mantid.
Oh, okay.
Yeah. And mantids are great things to have in trees. Why?
They eat aphids and mites and things like that.
They're predatory. That's right. That's what these big legs are for, and incredible speed. Eat lots of insects, which is desirable. And they have an unusual little reproductive component called an ootheca. And I don't know whether I can do that. I'll do it this way. This is praying mantis ootheca. Let's open it up. Looks like a bit of foam has been sprayed on the tree, on the foliage. And this has got hundreds and hundreds of eggs in it that will come out as young little nymphs. And again, most don't survive, other things predate on them, but they're really great to keep in the garden. And if I'm out somewhere and I see one, I've not I've been known to go and grab one and take it home with me to try and keep biological control going at home rather than having problems. So now you know what that looks like. It's one of those things that if you see in a tree, you have to weigh up, do I start looking at a spray program or do I just let the natural systems balance themselves out? And this is where spraying, if you see this and you start spraying, then you've probably lost half the benefit of natural control. And then you're stuck with spraying again and again and again. This is this big change between our days, early days, Rob, where you sprayed off everything. And in America, they definitely did, to an IPM, which says, we can have some damage, and particularly if we know that the population is heading back down. And we see that with lots of diseases that we control. I see a question in the chat. Old Blotchy is Tamil. Yes, Old Blotchy is at Tamil, southern coast. And Old Blotchy, unfortunately, lost 2/3 of a top, or his top, going back, I think it was about 14, 15 months ago. Okay, and our second one starts to get a little bit more difficult. And starts to get a bit more difficult. Because we're dealing with smaller things. Okay, whose sample's this? It was from Melinda Walker. Melinda's not around. This is from Canberra. So what don't we know and what do we know?
It's an eucalyptus. Which one?
It's certainly Metaceae. Probably.
The location?
Sorry?
The area, the geographical area, roughly?
Canberra. So
yeah, you know that.
Yeah. So this could be primary damage of a fungus, but it could also be secondary damage from insects that has then become fungally infected. But I'll say that there's a likelihood that it's had some fungal infection. And looking at it, again, I don't know what it is, but, something like Eucalyptus botryoides, Eucalyptus robusta, then it's Cardiospina. Same with its, I'm trying to think what their box is called down there. Meliodora. Meliodora is prone to Cardiospina albitextra in Canberra. So, but again, we're talking small things and not having a lot of information. So, and typically what happens is somebody will call you up and they say, my tree is doing something wrong, why? And often we don't have that much information to go with. So oftentimes we've got to give a probable or first stage diagnosis. This is where I think we start. And where do you want to go in terms of budget for testing? There's a limit. And having said that, we sent across samples in, I'm going to say 2004 to Gary Walker to identify the Cardiospina that damaged the grey boxes in Sydney. We lost 20,000 over 2 outbreaks, and it still hasn't been identified to species level yet. And, it doesn't matter how much time, resource and money, you get no answer, except that we know that it's a psyllid. And oftentimes that's all we need to know. And I would guess that that's probably what that was, a psyllid damage followed by a secondary infection.
Mark, sorry, what did you say the botryoides get affected by?
Again, a psyllid, brown lace lerp. It's an annual thing. And what they tend to do, it tends to, so which again is a Cardiospina species, brown lace lerp, LERP. Botryoides and it's robusta, it tends to be a winter infection. Or late autumn, winter, and by springtime, the trees respond by simply dumping the foliage and starting again. So they lose huge amounts of leaves and then the problem's gone. Having said that, there is a cost for that. And you wouldn't want to be seeing it repeatedly every single year. These eucalyptus leaves, everything going well, they'll quite happily survive several years. So, if everything's going exceptionally well, they won't survive several years, because the tree will be extending and getting rid of them. So it's not a huge issue that you get a year out of it, 9 months out of it. But cumulatively, it will become a problem over time. Okay, next one. I think that was it. I think that was Kane's.
Yeah, I think so.
Okay, great. Got a couple of others for you. And it's this one here. And to do it, I'm going to need to do this and say yes. Okay. Photos. Okay. This was down at Sydney University. I was down there looking at some trees the other day, and I saw this and I thought, well, that's a nice little example. What's your gut level guess?
Mites or thrips in here?
Mites could be, yep. Mites would do that.
Thrips, what about that?
Thrips will do that. One other will do it.
Aphids? No, so
Hemiptera.
much.
Let's go broader. Hemiptera. Aphids won't, because aphids are phylum feeders. These are what we call cytosol feeding insects that do this. Cytosol simply means the inside of the cell. So rather than trying to steal sugar out of the plant, they're eating the inside out of a cell. When they eat the inside out of a cell, the only thing they leave behind is the cell wall. The cell wall is largely cellulose and these things that are flexible. There's not as much lignin. And so cellulose has a high reflective index. It shines back. And so what you get is, instead of light being absorbed, you get light being reflected back. Cellulose is white and reflects. Okay, so these, and we call this particular effect stippling. Stippling means it looks like someone's got a paintbrush and gone around and dabbed the end of the paintbrush. There's lots of little dabbing sort of things. And see how there's lots of little spots? And these are all reflective individual cells that are being killed. And so you're getting them coalesced like that. So stippling is something that's feeding on the individual cells, on the inside of the cell. Doesn't mean that everything that feeds that way will do that sort of damage, but that's what it's, those organisms that do will. I say organisms because, of course, mites are not an insect by correct definition. I do have a tag discussion, and I do this every now and again, and I apologize, but just came up and I saw the shot and I thought I've got to. Tagging of trees is a really interesting thing. I wonder why we tag every tree. My view is we should probably just tag the trees that are of concern. But nonetheless, it get tagged. Some secondary side effects of tagging are there. And our recommendations are always stainless steel. Stainless steel, not just stainless steel, but stainless steel screws. There's a reason why we say stainless steel screws.
You can loosen them off after a while.
Back off a screw, you can't back off a nail. So inevitably, on dicotyledons, this will never get swallowed up, but on dicotyledon, you'll see the tags swell up, and then you end up with tags disappearing and breaking off, and then you end up with having to go through the whole process again. I guess it's good if you get paid to install tags, but if you don't, it's a bit of a pain. This is just in terms of how things deal with this. Is another one, the Brachychiton rupestris, another one that went through this drought stress. And you'll notice these young leaves are all hairy. Why do you think that is?
Juice, loss of water.
How?
Protecting the surface by the wind and air, so you don't have as much convection.
Yeah, it creates turbulence near the surface of the leaf. So often when young leaves come out, they have lots of these things called trichomes on them. And oftentimes they're shed. Our worst one, of course, would be probably London Plains. That's a stellate trichome. Stellate means star-shaped. I've only got to get one in, and they always want to just go right to the bottom of a lung. And then my body wants to immediately invert itself to try and get rid of it. So yeah, they can be quite irritating. So here's a palm that was on a site, and it all of a sudden started paling out, going yellow. Gut level guesses.
Is there irrigated area?
No, but Michele, for your sake and also for Melanie's, and I don't know where Mark's from, and for Rob's sake, he's Melbourne.
Overwatering, like bottom of the hill.
Yep. It's at the bottom of a hill, and we've had exceptionally high levels of rainfall up until about July or August of this year. Instead of getting our normal somewhere between 800 and 900, we're getting close to our 3,000 mils. So yes, very wet. So what's the wet problem then, Michele?
There's no enough oxygen in the soil. You have
But if there was,
die off.
if there was no oxygen, we'd be getting the margins dying off fairly heavily.
Dilution of nutrients then.
Yeah, some dilution occurs, but again, the tree generally controls that by blocking the aquaporins in the roots. But here I suspect that the most common thing is you get iron fixation. So iron gets fixed in saturated soils. Okay, and so when the iron gets chemically bound, it's not available, so you get an iron deficiency. And so that's my gut level on that. I can do two things. I can do a soil and tissue analysis. That would be the nice way to do it. Charge the client another $500 or $600, or suggest that he tries a chelated iron solution that he can spray onto the foliage because it's absorbed through the foliage. If it greens up, then we know we're heading in the right direction. If it doesn't, then go out and get a test. So, do a quick little $40 or $50 experiment versus go out and do the full analysis. And that's
how long will it take to green up?
4 to 6
2
weeks.
Yeah.
Yeah, fairly quick.
Depending on the time of the year, though. If you do it during the cooler months, might take longer.
And the same thing goes when you see the typical magnesium deficiency on those indicator plants like gardenias. What else? Murraya will do it. Those things that turn chlorotic fairly quickly. Again, just some Epsom salts, do a quick treatment. Don't keep on doing it. Just if you don't see an improvement, then go back to saying, look, we'll do some testing now rather than, randomly trying other things.
What do the Epsom salts do, Mark?
Manganese, replace manganese in the soil. So manganese is one of those things that helps give rise to the green color.
Mark, in your inbox, you've just got some photos that Melanie sent that I neglected to pass.
Oh yeah, you're neglectful.
Oh, thank you.
Really, Peter? In my inbox. I think I never do any work. Send, receive. Thank you. Oh, we've got some fun here. Okay. Chili Americana. We've got chili Americana down in Hobart.
Mm.
So
There are a few different Tilias in that garden, and that the Americana has been in decline for a few years.
yeah, well,
Since I've been there.
it's got a
and
fungal infection. Have you
Yeah.
thought about, and again, I don't know whether this is doable, you can't eradicate the fungus. We just don't have fungicides that do that job for us. So most of them we have to live with. But if you thought about mulching and extending the organic land, the reason why is saprophytic fungi are very antagonistic to pathogenic fungi in general, particularly those that are in the soil.
Yeah, we could mulch around it. Yeah, we thought we'd fix the irrigation, so it's at the bottom of a hill, and the soil was very saturated, and that discovered an irrigation leak when they did a $100,000 new irrigation system in the historic rose garden. But yeah, it's still, I neglected, sorry, I got really focused on the fungi and forgot to send a picture of the actual tree, the above ground appendage, but
it's a stressed tree.
it looks like crap, basically.
Yeah.
That if you want to put it in
It's
technical terms, it's stressed. Yeah.
It's
Yeah.
a hard stage to be dealing with when you've got significant strain that's occurred and you've got to try and rebuild a tree. Having said that, trees like that do and are able to be turned around, not reliably, but I've seen trees that I've just thought, you know, why would you bother? But hey, you know, for the $100 of trying, why not try? And
Yeah.
back that make me often laugh and think, you know, it really isn't something we should be always throwing away. So that's the first thing is I'd look at is putting in some organic material.
Okay.
Taking advantage of the organic material, of course, providing solutes back into the soil.
Now, the fun thing is I just found another one at the base of a Malus floribunda that's probably about at least 80 years old, diagonally across from the rose gardens at the top of the hill. So that, yeah, the one that you're looking at right now. So same, I don't know, is that a Ganoderma? I'm guessing.
No,
It's perennial.
Yeah, it would be all guesswork.
Yeah.
Just not enough there to even start.
Yeah.
You've got a sporocarp there. There's no questions about that. It looks like there might have been an older one down here.
Yeah.
In terms of these fungal diseases, often there's an inclination for us to say, well, we've got a fungal disease, that's the end. And there's a point to which that's true, particularly with the nastier ones. Armillaria and Armillaria luteobulina, that is, and Philonus noxious. But for a lot of the others, you know, you can see the trees linger on for decades, and sometimes not with any big setback. The only thing I'm concerned about now on the tilia is what's happening below ground in terms of stability. You've had some
Right.
and that's something to think about.
Okay.
There's some things you could look at there. You could either look at static testing or a tree motion sensor type sensing. Static testing, wait until there's no one around, find a direction that the tree can fall in. If it does, it's not going to be an issue. Put a rope in it, get 2 or 3 guys, stand back more than the height of the tree away and give it some pulls and see how it moves and see if you can see any movement at ground level. And whilst that sounds horribly rudimentary, it was how Redwood City developed its sidewalk repair program. They would go through, cut roots, and where they were concerned about it, they would pull in if they saw movement of the tree that was obvious with 3 or 4 guys giving it a good pull. They're not pulling to failure, just seeing the sort of movement level. Typically, a tree loaded is going to have less than 1% movement. So it's not a very large amount of movement at ground. It's difficult to perceive. So if you're seeing a lot of ground movement, then you may want to get rid of it. The good side is tilia are incredibly resilient as a species. I mean, I think they come very close to equal with ficus and platanus as a species that want to survive and will do things to survive that are just wonderful.
You can see it in their branching pattern, the way they just keep branching, growing. Yeah, if they fail in one spot, grow in another.
You can see it in lots of things that tilia do.
Yeah.
They are truly a spectacular tree and sadly underused in Australia. Rob, you're from Victoria, aren't you?
Yeah, well, we see quite a lot of them in Melbourne, and they're just beautiful trees. And apart from the resilience, they're beautiful trees.
They are a beautiful tree. Yeah, I haven't noticed as many in Melbourne. Of course, when you get overseas, they're prolific.
There's quite a few in the new estate development.
We have some lovely old ones in that rose garden. There's an avenue. There's a lovely semicircular avenue outside of Parliament Garden, so outside of Parliament House, and then also around the town hall.
Yeah. Now, when you say they're old ones, you mean old by Australian standards, because
Yeah, yes.
Tilia is quite happy
Probably,
to
yes, probably
100 plus
100 years old.
And
Yes.
it's, again, one of my things today was trying to explain to a client why an age class was somewhat nebulous and meaningless.
Mm,
You know, a better thing to do would be to consider vitality, and then I wouldn't want to do that on every tree. I'd just do that on a case-by-case basis. But yeah, when you start talking about 20% of a life for a tilia, you know, 200 years is probably makes it a young tree.
yeah. Well, that's what I loved about your talk at Arbaugh about traditional trees and shield tree, like how old what's the DBH of the tree, and it would have to be
Yeah, look,
a very large tree to be that old, and that was such a good point.
and we're not good at estimating tree age. I mean, I've forever amazed at how incompetent I am. And I'll look at a tree and I'll say, oh yeah, that's got some good age. And then I'll go to New South Wales government is digitizing all of its maps. And so we're getting more and more come online. And there's a link you can go to search by photo series, each run they did with the plane. And you'll sit there and think, oh yeah, that's a, 70 or 80-year-old tree, and you'll, 5 or 6 shots later, you'll say, okay, it's a 1970s or 1990s, and you think, oh boy, I'm just, and overestimating is the bigger problem, not underestimating. We tend to look at trees and say, well, that must be 80 or 100, rather than, boy, that could be 30 or 40.
I don't know, Mark. I'm constantly seeing arborist reports that claim this tree is 350 years old.
I've got a telephone call with an architect. A guy lost 2 units on a development to preserve some remnant trees until I found the 1985 aerial image with no trees on the site at all. And I said, they're probably not remnant. And it's just so easy to get wrong. Craig Hinton gave a talk about 3 or 4 years ago that was really good at one of the Arbaugh conferences on looking at accuracy of data collection. So we're really good at height. We're really good at DBH. That's our most reliable. We're not so good at spread. We're not less good at height. We're less good at age still, and we're really hopeless at life expectancy, useful life expectancy. You'll look at a tree and you'll say, well, that's going to die. And then 3 years later, when you look at it, you say, oh, that's in great condition. And then you see trees that are in great condition, and 3 years later, you go back and they're dead. And you say, okay, well, that's just a potluck guess on that. So I think DBH is a useful thing to collect in terms of information. That would be where if I was collecting a database, I'd tend to focus my interest.
Okay.
One thing I say when councils ask me to give a safe, useful life expectancy, I say that in my reports, I hope to be factual and not use something that is purely speculation.
Yeah. It was a tool to be used under the British standard to assess trees on development sites to determine which trees would be given priority. When the British standard changed, I think it was 2002, it became the Tree AZ. Jeremy Burrell developed in both cases, and Tree AZ replaced Sewell. We don't use it for development site work in most cases. We just use it because it sounds a smart thing. What we're really asking is, how long do you think this tree is going to be suitable for this site? And so we might as well just give a site suitability rating and say, look, this is good, this is fair, this is poor. And again, how do you interpret that? I agree with you, Rob. So much of what goes on with data that we collect is a little bit of voodoo magic. And, you know, we've got to try and weigh that up. Now, some of it's useful, but, you know, if you're not measuring the height of a tree, for example, knowing the height's almost useless. Because if I've estimated it's 20 meters and you come back in 3 years' time and estimated 18 meters, you say, well, the tree's going backwards. And then McKellar comes out 4 years later and says, no, it's 28 meters, and he's measured it. He says, well, this tree's in a great condition. Look how fast it's growing. All of that's erroneous, the whole lot. So,
and measuring as well is not that easy, because lasers are not as accurate when you point them to the leaves.
No.
And sticks, and if you to measure in sticks, sometimes you got get the angle right, and even the measuring the height, you got to climb it and put a rope down. That's it.
Yeah, we agree. Rope down, and then you pole meter to the top, and that's the correct and formal way of measuring. And so what? What's the point of it? In most cases, I'm not building things over the top of trees. So knowing the height is probably not critical. Knowing the diameter, on the other hand, if I've measured that correctly, and again, there's a degree of error, you know, that when we're doing DBH, it's probably got, you know, 2 or 3 centimeters of variation, depending on how close you are to 1.4 and how much you move your tape around, and, you know, how much bark's there and what's doing, all those things. But at least that gives us an idea of how the tree is performing. There's a direct correlation between trunk diameter and increase in trunk diameter and the health and growth of the tree.
Mark, can you have a look in your inbox on the 11th of January? There's another set of photos that we haven't looked at.
Oh, okay. I go back to that, no trouble. So sorry, I missed it.
From Gareth.
From Gareth. Gareth, oh, look there. You're right. I'm a bad man. Oh, I do recall seeing it. So there we are. I'm extra bad. And it's a good one too. In the vlog from Gareth on the 11th. There it is. I'll just pull one of those over and enlarge it for you. And I will make this the last for tonight. Not this image, this issue. And I'll enlarge it. We all see things like this. This is Melaleuca, goodness knows what species, Stiphyloides by the looks of it, but it might not be. And you've got this clustering of
could be Bracteata.
It is Bracteata, was it? Thanks, Peter.
Could be.
Clustering of leaf tissue and lots of them there. Anyone ever seen this? You'll see it in Casuarina very regularly.
Witch's broom?
Witch's broom, yeah. And a witch's broom is simply a messing with the genetic material. And that's a nice and simple answer. What messes with the genetic material? The plant itself.
Virus.
Viruses, yeah. Insects can spread it. Insects can do it. So mites, for example, I said to you earlier on that mites can cause that shortening of the node, lots of weird tip damage that looks like a clustering of the shoots. So I had a student bring in a sample one day and slapped it down on my desk, and we said, yes, we'll get to it. And we didn't have to get to it because as we're got the microscope playing in the background, you start to see mites crawling all over the place. Thousands and thousands of mites in the spore sample. Every now and again, these stay permanent. That is, they keep this altered genetic coding. And particularly when they're virally induced, sometimes that changes things. We know that when you cut the tail off a mouse, that its offspring will have tails. You know, Lamarck's proposed chop tail off, offspring no tail. And he was wrong. But when it comes to plants, if you alter genetic material, all material that's generated from that meristematic tissue thereafter, or that parenchyma is meristematic tissue, has the altered genetics. And that's how we get a lot of our variegations, our prostate forms, our unusual plant materials. And there are people that go around, and there's two sorts, there's big game and small game fisher. They go out looking for variegations. The most famous one is Capressa sempervirens stricta Swain's golden cypress pine. And Ben was driving back from the Southern Highlands, saw a little sport growing on the side of a green specimen. He said, "Oh, look at that. I'm going to give it a go." Took the cutting, took it back and propagated it. And of course, everything that's propagated from that now has that same genetic coding. So lots of things can cause it, often not an issue. Sometimes can be of interest, sometimes can be of horticultural interest. I found, I got a witch's broom. There was a propagator who's doing Corimbia in Queensland, and I got him to do some witch's brooms off Corimbia, and I have 2 semi-prostate Corimbias, Corimbia citradoras in my yard. He said he'd never do them again because they stank. But apart from that, yeah, just let you know what you can play with. And you know, there's certainly merit. What would I do about it? Nothing. I just let the tree correct it by itself. If it was extensive to the tree, then I might think about trying to worry about the cause. But in most cases, you know, it's probably less than 10% of the foliage, and they're still photosynthetically capable. So they're still doing their job. Oftentimes they weep. Oftentimes they don't put as much woodiness on them. They don't have as much apical dominance, but that doesn't seem to be a problem. Anyone else got any comments or thoughts on those guys?
How deep does it go? Like, let's say aesthetically you wanted to get rid of it. Could you cut it? Cut it back and yeah.
The note beforehand, they're really easily removed that way. In the earlier days, that's exactly what we used to do, Melanie. Now I'm getting my age away, Rob. So yeah, we saw witches' brooms. They were considered to be diseased tissue when you remove them. But nowadays we'd keep them like the same as we see mistletoe. In fact, this is better than mistletoe because it's not robbing anything. It's actually contributing. If it doesn't contribute back to the system, the tree will isolate it off and kill it.
Yep.
So we know it's contributing to the system. So, you know, the fact that it's got a bit of abnormal growth, in another 10 or 15 years time, you guys will start to know what we're talking about. That happens to human beings. You get your skin start to grow little bits and pieces everywhere, and you think, well, what's happening there? And this is doing the same. And the older a tree is, the bigger a tree is, you know, the greater the likelihood that something like that's going to happen, because this tree's already had, probably by this stage, 1 trillion plus buds, you know, and wow, you know, one of them's gone a little bit AWOL. Okay, guys, I'll see some of you next week. We're looking at arborist reports. Otherwise, I'll see you in a month's time.